Today we're going to begin our similar polygons unit, and this is in the similarity chapter, and we're going to talk about what similarity means. And basically, in my own words, two objects are similar if they have the same shape, the same number of sides, and all their angles are the same, but one is just much bigger than the other. It's kind of like when you blow up a picture of something on like an iPhone or an iPad or something. If you can blow it up or you can shrink it, the rigidity of the object stays the same, but it's either much bigger or much smaller. So for similarity statements, we have this symbol right here, this little squiggly line, and what that means is similar. So it means they're not the exact same, but they do have a lot of the same qualities. One's just much bigger than the other. And the way that these letters are ordered corresponds to the way that these letters are ordered. So the first thing I like to do is match up all the angles. You can see how the very first letter in this trapezoid is letter A, and the first letter in this trapezoid is letter E. And that tells me that those angles are congruent. So angle A is congruent to angle E. Okay, and then the next pair of angles is going to be angle B, the second letter, and the second letter of this trapezoid. B and F go together. So I'm going to mark those congruent. B and F go together. And then you can see the third letter is C and G. Those go together. And the last letters of each trapezoid, D and H, go together. So those are my angle pairs. I'm going to list those over here on the right. And it's just the order of those letters is super important in any similarity statement. The order tells you exactly what angles match up. So we have angle A congruent to angle E. We have B and F. And we have C and G. And we have the last letters. D, oops, not comma, is congruent to the last letter in the other trapezoid is H. And that's what I marked congruent in my picture. Okay, the next thing we're going to do is talk about how the segments are proportional to each other. We can make fractions out of all of these segments, and they will all reduce to the same fraction, and that's what similarity kind of has intertwined in its definition. So the first two letters of the first trapezoid are AB, and if you make a fraction with EF, the first two of the other trapezoid, that fraction is going to reduce to the same fraction as, let's do the next one, let's do BC, the middle two letters, and the middle two letters over here, BC and FG. And now let's go back up to our similarity statement. The order of those letters is the most important part. So let's do the last two letters, CD and GH. You can see right now what we've done is we did A, B, and EF. We did BC and FG. We did CD and GH. So you can see what's left over. The only side that we haven't made a fraction out of yet would be these two, AD and EH. And those happen to be the first and last letters of each trapezoid, first and last. So my fourth and final fraction is going to be AD and EH. So you should always be able to set up 4 different pairs of angles for each quadrilateral, because there are 4 sides and 4 angles, and 4 different fractions that should all reduce to the same number whenever you have any two similar quadrilaterals. Now let's talk about similar triangles. So the way to tell if they're similar is we need to make fractions like we just did of each of the corresponding sides and see if they all reduce to the same number. So what I like to do is I circle the smallest side of each triangle. So in my triangle VIK, my smallest side is the 4. And my smallest side of NGS, that smallest number is 12. So I'm going to make a fraction out of that. 4 over 12. Is that equal to, and I'm putting a question mark because I'm not sure if they're going to be equal yet. That's how I'm going to answer the question. Let's do the middle side. The middle side length is the 5. and the middle side length of NGS is 15. And is that equal to the biggest side ratio? The biggest side over this one's the only one that's left is 7, and this one is 21. Let's reduce all three of those fractions and see if they're all three the same number. So 4 over 12, I can divide top and bottom by 4. That's going to give me 1 over 3. Is that equal to, let's do this middle fraction. I can divide top and bottom by 5. That's going to give me 1 over 3. So we're on to a good start. We need to check all three fractions just to make sure all three of them are equal. What is this top one reduced to? We can divide top and bottom by 7. So, oh wow, 1/3 equals 1/3 equals 1/3. So my answer is yes, they are similar triangles. And notice I used the similar, the little symbol that we just learned. Whenever you're answering a question, are they similar? Yes, similar triangles. And my answer is because every single side length ratio reduced to 1 over 3. If one of them would have reduced to 1 over 4, then my answer would have been no, because it wasn't all the same fraction. Okay, last example. They're telling me in this similarity statement up here that these two triangles are similar. So remember what you know about the order of those angles. That means that angle R, since it's first, is going to be equal to angle G. So those are my top two angles. The middle letters are going to be equal, so S and H. And the T and the J are also congruent. Okay, so what we're going to do is we are going to set up our own proportions and see if we can solve for x. So I'm going to do this two different ways because somebody sitting next to you might set up a different fraction than maybe you did. I'm going to set up these two left-hand sides of my triangles, the two numbers that are in between the 1 swoop and the 2 swoops in each triangle. See how those sides correspond? They're in the same location and they're in between those two angles that I marked as congruent. I'm going to make a fraction out of 10 and 15. And then I'm also going to do the bottoms of the two triangles, x and 9. And notice that I put the 10 and the x, since that's from the smaller triangle, I put those on the tops of my two fractions. And the 15 and the 9 are of my bigger triangle, and I put those on the bottom. You do have to stay consistent in where you put your proportion numbers. Now all we're going to do is cross multiply. We did this on the previous lesson. 15x equals 90. And if you divide both sides by 15, we get x equals, anybody good at mental math? 6. Okay. So that was comparing the 10 and the 15 and the x and the 9. Here's another way that you could have done it. We didn't use the 8 or the 12, but we totally could have. So we could have done 8 over 12, because those are the two right-hand sides of the triangle. And those are in the same location according to the angles that we marked, so the 8 and the 12. And I'm still going to use the x and the 9. Excuse me. And so again, we're just going to cross multiply. So we get 12x, keep the equal sign. 8 times 9 is 72. Divide both sides by 12. And you get x equals 6. So we got the same answer either way. And it's just by setting up a proportion and solving.